Hi, welcome back to our channel. So in this video we're going to look at question 4, which requires us to approximate the integrals using the composite Simpson rule. So in the previous video we have looked at the composite trapezoidal rule, and this question is particularly asking us to apply the composite Simpson rule. And we have three questions on question 4, like this: question 4a, B, as well as C. Okay, so I'm just going to answer one of them. Then in the same order, you can try to go through the other two that I'm going to leave out. If you need any, if you come across any challenges while doing it, you are free to get in touch with me um, on WhatsApp using the contact that I'm going to leave in the description. Okay, so as well as after doing that, we have to determine the value of n and h in respect to that particular question that we are doing. Okay, so let's get into this and see how it works out. Actually, let me see, which question am I picking. I'm going to pick the second question, okay, which is B, because I was going to pick the first one, but the first one is pretty similar to question 3a, which is what I did in the previous video. Okay, so I'm going to do question 4b, which is the definite integral from 0 to pi of the function x squared multiplied by cos x. Okay, and we are told that n is equals to 6. Okay, let's see how this works out. So we have this function from 0 to pi, then this is x squared cos x dx, and another information we are given is that our n is equals to 6. Okay, so maybe before I do everything else, I would want to find what the exact value is. Okay, I would want to find what the exact value is for this. So what I'm going to do is to integrate this by parts, then evaluate and see what value I'm going to get. Okay, so so we say exact value is what we are looking for first. Exact value. So what we do is that using integration by parts, I'm going to choose which one of these is going to be my u, which one of them is going to be my dv. So it's using this here, liate, liate, is this guides us to choose to know which one we're choosing as our u. Okay, so in this case, the the algebraic function comes first before the trig function. Okay, so that's the one that we are going to choose as our u. And objectively speaking, if I was to choose my dv to be equals to x to the power 2, it simply means this power is going to be increasing, because the essence of using the integration by parts is that you want to make sure to say you only have one function here, because that's a product of two functions. So if I keep on integrating this one here, it will remain to be an algebraic function. It will never be a constant number. Okay, the only way the only way it's going to be a constant number is if I differentiate it. But when it comes to this trig function here, no matter how many times I integrate it or differentiate it, the result will always be a certain trig function. Okay, so that's the reason why we are choosing our u to be equals to x squared, then our dv to be equals to cos x, like that. So our du is just going to be equals to 2x dx, then our v, which is the integral of cos, is simply sine x, like that. So remember, using integration by parts, we say it's u dv is equals to uv minus the integral of v du. So basically, we're just bringing our u here. What is our u? Our u is x squared. Our v is sine x. So that's going to be x squared sine x. And remember, you are evaluating this from what? From 0 to pi. Then I'm going to say minus v du. Okay, this is our du and this is our v. So it simply means you're saying 2x dx multiplied by sine x. I can bring the 2 outside, then I have x sine x dx, like that. And this is from 0 to pi. So for simplicity, let's try to evaluate this one. Of course, we are still going to get back to integrating this one. If we try to evaluate this one, is that the upper limit, for the upper limit, which is pi, we're just going to say is pi squared. We're going to say is pi squared, then sine pi minus 0 squared sine 0. This part here gives us a 0. What about this part? So this part also gives us a 0. In radians, sine pi is 0. Okay, so this part here gives us a 0, and we don't really need to waste much time having to include it here. So you're going to say that is equal to this part. So once again, we are going to use integration by parts for this one, meaning we are going to choose our u to be equals to x, then our dv to be equals to sine x, meaning our du will be equals to dx, more like 1 dx, but our v will be equals to minus cos x. And applying integration by parts, we say u by v. Okay, here it's going to be minus x cos x evaluated from 0 to pi. Then you are going to say minus, but remember you are saying v du. Your du is simply positive dx or 1 dx. Then your v is minus cos x. You're supposed to say minus, but since you're going to have more like from 0 to pi, okay, from 0 to pi, here just more like it's going to be like cos x by dx. Remember, this cos has a negative here, but I don't have to put it there. What am I going to do? Multiply by that negative, it becomes positive. And remember, everything here, this is multiplied by what? Multiplied by that negative 2 that is outside. So we say this is minus 2. Okay, so one thing you observe is that if you integrate this one, you're just going to end up with what? It will be sine x evaluated from 0 to pi, of which everything here gives you what? A 0. Sine pi is 0. Sine 0 is still 0. So we worry not about this part here. Let's get to focus on what we have here. Okay, so this is going to be like minus 2 in the brackets. You substitute here. That's going to be let me say minus pi. Okay, minus pi cos pi, like that, then minus, but it will be plus actually because of this negative here. Okay, so that is going to be 0 by cos 0, like that. So what is this? This here gives you a 0. Of course cos 0 is a 1, but because you're multiplying it by 0, you get a 0. So cos pi is negative 1. Okay, so this is going to be negative 1 times negative pi. That's going to be positive pi. So positive pi by negative 2, that would be minus 2 pi, like that. Okay, and that happens to be our answer. So minus 2 pi is our answer. If you punch that on your calculator, you're going to end up with so we can say exact value is equals to, so exact value is equals to minus 6.283185307, like that. Okay, so that is our exact value. Let's go ahead now and approximate this using composite Simpson's rule. Okay, so just to remind ourselves, the formula that we use for composite Simpson's rule is the integral, okay, the definite integral from a to b of f of x dx is approximately equals to, you have your h divide by 3, then in the brackets, okay, we use the square brackets here, we're going to have f of a plus 2 by the summation of course we are starting from j is equals to 1 to n over 2 minus 1, okay, of f of x to j, x more like x sub to j, like that, plus we have 4 by the summation of we are starting from j is equals to 1 to n over 2 of f of x sub 2j minus 1, like that. Then we have f of b here, like that. We have the error part, but I'm not going to include it. So the first thing that we can do is try to consider what this is and what that is, because obviously we know what our b is. Our b is pi and our a is a 0, so it's easy to substitute for those. So let's look at this one and see what it basically means. So here, one thing you know is that your x sub j, okay, from the composite trapezoid rule, x sub j is equals to a, which is our initial point, plus jh, like that. Okay, so when it comes to this one here, x sub 2j, x sub 2j will be equals to, it will be a plus 2jh. Okay, meaning when it comes to this one here, that we are where we are subtracting 1, is x sub 2j is equals to a plus 2j h minus h, like that. It's more like you can write it as a plus h here, then you have 2j minus what, minus 1, which is basically what is right here. Okay, so that's one thing that you have to remember. So I'm going to compute in advance what this one is, as well as what this one is, so that we just go ahead and substitute this one, I mean on this part, and see how we can simplify it for ourselves. So for x sub 2j, we say this equals to, what is our a? Our a is a 0 plus 2j multiplied by h. Do we have our h? Not yet, but we can find it, because h is basically equals to b minus a divided by n. What is our b? Our b is pi minus a, which is a 0, divided by n, which is a 6, as we are given. So basically, h is equals to pi over 6. Okay, so this is just going to be multiplied by pi over 6, of which, if you simplify, that's going to be j pi over 3. That's what it is. Okay, so I think I can substitute it here. So we are looking for f of j pi over 3, like that. Okay, so what about the other one where we are subtracting a 1, or an h rather? So when we say x sub 2j minus 1, we say it's equals to our a, which is 0, plus 2jh. Our h, we said, is pi over 6, okay, minus pi over 6, like that. So here we are going to get something like j pi over 3, okay, j pi over 3 minus pi over 6. If you make this a single fraction, if you wish so, that's going to be 2j pi minus pi divided by 6, like that. Okay, so that's exactly what I'm going to substitute right here. Okay, so we have 2j pi minus pi, okay, everything here divided by 6. So this is what we are going to be using. So it was important for us to do that before we go anywhere. And once again, for simplicity, let me just substitute this one in advance and this one in advance. We see what we are going to end up with. So our f of a is more like f of 0, because our a is a 0. So we substitute, that's going to be 0 squared multiplied by cos 0, which is going to be 0. And we say f of pi, which is our upper limit, or f of b, which is this one here. This is going to be equals to, that will be pi squared by cos what? Cos pi, which is a negative 1. So here I'm going to get negative pi squared. Okay, negative pi squared, which is equals to something like, it's a value with a lot of decimal places. So what I'm going to do for now, by the way, there's a plus here. For now, I'm just going to substitute a minus pi squared. I'll just say minus pi squared. We'll break it down a little bit after we are done with the first part, or the middle part. So this, we get a 0. So we have a 0 here. Okay, let's go ahead and work these two out. So if we start with this one, what that one is that here you're going to substitute the value of n, which is just 6. So that would be like 6 divided by 2 minus 1. Okay, 6 divided by 2 is a 3, minus 1, that's going to be a 2. Okay, that's going to be a 2 right there. So I can actually just place in a 2 here. Okay, on this one we're going to have a 3 because 6 divided by 2 is just a 3. We're not subtracting anything, so that's just going to be a 3 like that. Okay, so I'm just using the main formula to make all the substitutions, and we see how it can work out. So we're basically going to say 2. I'm starting with this one here, the middle one, or the first one. This 2 multiplied by the summation uh, from j is equals to 1 to 2 of f of j pi over 3. What this one means is that if you're going to say 2 here outside, in your brackets you're going to be substituting. You're going to say f of, where this j, plug in 1. We are starting from 1. Okay, we are starting from 1. That is going to be pi over 3 plus f of, plug in 2. That's going to be 2 pi over 3 plus f of, plug in 3. That's going to be 3j pi over 3. That's just going to be j, sorry, that's just going to be pi rather, like that. Okay, do we really have to go to 3? No, actually we're not really going as far as, we're not going as far as a 3. Okay, we're not going as far as a 3, so it just ends there. Yeah, we are going as far as a 2. So it simply means now we can substitute. We say 2, okay, f of, so in this function here you substitute, where there's x you put pi over 3. So if you say pi over 3 squared, it's going to be pi squared over 9. Okay, then cos what, cos pi over 3 plus, okay, this one you plug in where there's x squared, that's going to be like 2 pi over 3 squared, that's going to be 4 pi squared over 9 cos 2 pi over 3, like this. Okay, so if you punch this on your calculator, if you go to your calculator and you work that one out, you're going to end up with some value, and I'm just going to place it here. So let me just erase that part. Like, just punch all of that on your calculator and you're going to end up with some value that is actually negative. And remember, there is a 2 here, so you obviously multiply it by 2. So you're going to end up with some value that is something close to or similar to or exactly like this one, minus 3.289868135, something like that. Okay, so we have worked out that part. Let's go ahead and work out the other one. Okay, so let's go ahead and work out this one in a similar manner. We're going to say it's 4 multiplied by this summation here from j is equals to 1, j is equals to 1 to 3. So we have f of 2j pi minus pi divided by 6. This will be equals to, I'm going to have a 4 outside here. I'll start substituting the value of j. So if we say j is equals to 1, that would be 2 pi minus pi, which is just going to be f of pi over 6 plus, we pick now is j is equals to 2. 2 by 2 is a 4, so 4 pi minus pi, that's going to be 3 pi. So that's just going to simplify to pi over 2. Is it? Yeah, pi over 2. Okay, then we say f of, if we plug in 3 by 2 is a 6. Okay, 6 minus pi, 6 pi minus pi is going to be 5 pi, so that's just going to be 5 pi over 6, like that. And that's the furthest we can go because we're just having 3 of them, 1 2 3, because of these 3 that we have here. So if we substitute in the function that we are given, so we've put 4 outside, so where there's x here, plug in pi over 6. That's just going to be pi squared over 6 squared is 36. Then you say cos pi over 6 plus, you plug in pi over 2 where there's x squared, that's going to be pi squared over 4. Then you put cos pi over 2, which is obviously a 0 because cos 90 is a 0 plus. Then here we are going to plug in 5 pi over 6 where there's x squared, that's going to be 25 pi squared over 36 cos 5 pi over 6. And if you punch that on your calculator, I'm just going to plug in the value here. You're going to end up with a value that is also negative. Okay, a value that is also negative. It will be minus 22 point 22.79287,503, like that. Okay, that's the value that we get. And remember, our value of h, we said the value of h is b minus a divided by n, which is a 6 in this case. So that's just going to be like pi over 6. So we just have to substitute pi over 6 where there's h here. So if we say pi over 6 divided by 3, this is basically pi over 18. Okay, because 3 by 6 is 18. That's going to be pi over 18. Then we do that, you plug in everything that you have inside here, minus 3.289868135 minus 22.79287,503 minus pi squared. Okay, so this is just going to end up to give you a value that is like minus 6.274868,388, like that. So one thing we have determined is that our approximated value, okay, our approximation is equals to minus 6.274, okay, 274,868,388. That is our approximated value. Okay, so that's basically what we were looking for. And you can actually compute the error if you like. So your error, keep in mind that your error is just equals to the absolute value of the exact value, okay, exact value here minus the approximated value. Okay, approximated value. And when you compute those, you're going to end up with some error that is like 0.008316918, like that, and that's going to be your error. Okay, so we have approximated this integral here. The second part of the question is asking us to determine n and h required to approximate the integrals in a to c within 10 to the power minus 5. Okay, so this is also pretty basic. Of course, it really has nothing to do with the errors we have found, and this n that is given, we don't need this n, we are not using it. All we need is just a function, and we only need few components of this function, I mean this integral that we are given. So our error, okay, our error is the one that we are going to use to find the value of n and h. Okay, so our error, we know to say by composite Simpson's rule is minus b minus a divided by n, sorry, not n, 180 multiplied by h to the power 4 by f to the fourth, like the fourth derivative of we say mu there, like that. Okay, so let's go ahead and compute the fourth derivative first, because we have observed to say that's what we are going to use. So our f of x, we are given as x squared cos x. So our f prime of x, okay, f prime of x is just the first derivative, and this is a product of two functions. So what you do is that you just use the product rule, because it's a product of two functions. So what I can do is that this is going to be 2x when I differentiate x, then I'm going to have cos x plus. If I differentiate cos, I'm going to get minus sign, so obviously this is going to be minus x squared sine x, like that. So what about the third derivative? Sorry, this is not the second derivative, this is the first derivative. Okay, this is our first derivative. Our second derivative will be equals to, for this part, this is going to be 2 cos cos x plus, it will be actually minus 2x sine x. Then we are going to say minus, you integrate, you differentiate x squared, that's going to be 2x sine x, minus, you differentiate sine, that's going to be x squared cos x. And if you um, simplify this, this is going to be equals to 2 cos x. You have this one and this one, that's going to be minus 4x sine x minus x squared cos x. You say cos x like that. So your third derivative, f prime 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 of x, is just going to be equals to, so that the derivative of 2 cos is going to be minus that's going to be minus minus 2 sine x, 2 sine of x. Then here we say minus 4 sine x minus 4x cos x. Then here we say minus 2x cos x plus x squared sine x. Okay, from this you simplify it, then differentiate again. You're going to find that your fourth derivative is just going to be equals to, let me actually write it here. Your fourth derivative, f to the fourth of x, is just going to be equals to 8x sine x plus x squared cos x minus 12 cos x. Okay, that's our fourth derivative. We really needed to have it because we are going to have to evaluate. Okay, so the reason why I'm particularly doing this, okay, is we have to evaluate at these points, this point as well as that point. So here's what I mean by evaluating. We are going to have to look for f to the fourth of 0, like the fourth derivative evaluated at what, at 0, like the lower limit. So here you're going to say it's 8 by 0, okay, sine 0, like that. Then you're going to say plus 0 squared cos 0 minus 12 by 0. Okay, so this actually just ends up to be this just actually ends up to be minus 12. Okay, so this is minus 12. Then what about f to the fourth at pi? Okay, so that would be going to be 8 pi by sine pi plus pi squared cos pi minus 12 cos pi, like this. Okay, and this just ends up to give you something like minus 2.130 39, then 5599. Okay, so when it comes to the error, we are going to write it like this. It's the absolute value of the error, okay, less than or equal to b minus a divided by 180 multiplied by h to the power 4. This is going to be multiplied by the maximum, okay, the maximum value of the absolute value of what, our fourth derivative. Okay, here I'm going to use mu. Then our mu is in between a comma what, a comma b. In this case it's 0 comma pi. I'll say 0 comma pi here, like this. So what it means is that this part we are multiplying it by the maximum from the derivative after we evaluate at 0 and what, and pi. Okay, so once again it's just to take the absolute value of this and the absolute value of that. So if we say absolute value of f to the fourth of 0 is just going to be equals to minus absolute value of minus 12, that is going to be 12. Similar to this one, it's just going to be a positive value, which is 2.13039 and those values. And we observe to say the maximum is what? Is 12. Okay, so here it simply means I can write this as your b is pi, obviously. That's going to be pi over 180 multiplied by our h. Okay, our h we don't know. It's our h is what we are looking for. So just going to say h to the fourth, okay, multiplied by 12. Okay, this is going to give you something like 12 into 180 is 15. So you're going to have something like pi times h to the fourth over 15. Is it 15? Yeah, it's 15. So now to get our h, we're going to say pi pi to the fourth over 15. This is supposed to be within 10 to the power negative 5. Okay, so it simply means you can say pi h to the fourth is less than 15 multiplied by 10 to the power minus 3, like that. So you just divide both sides by pi. This is less than 15 times 10 to the power negative 3 divide by pi. Then you take the fourth root. You're going to end up with your h being equals to your h will be 0.083125495. That will be your h. And remember, we're also looking for the value of n. So your n, we said our n is just coming from the value of h. How is it coming from the value of h? What we know is that our h is equals to b minus a divided by n, meaning n is equals to b minus a over h. So if we say n is equals to pi, which is our b because a is a 0, divided by 0.083125495, you're going to end up with some value, something like 37.79337043. So just write this to the nearest whole number. That's just going to be 38. So n is 38 and h is equals to 0.083125495, and that's basically our answer. So that's all in this video. Thank you very much for watching, and we'll catch you in the next video.